This video is on the Vogel's approximation method, also abbreviated as VAM. So this is just one of the three methods that we use to calculate the initial feasible solution, which are northwest corner method, you have the least cost method, and finally VAM, the one we are actually focusing on in this video. So let us get underway and try to solve a question using VAM. So suppose you have this question. Let me just write it out on the screen. Suppose you have a question like this. So you have a box, your columns there, your rows, and then you have these costs, should I say values, 6, 8, 10. Okay, there are small boxes in the corner there. The next one can have a 1 there, 11, another 11 maybe. Then here we can put 4, the other one can have 5, and lastly we can have 12. So given such cost values, you'll be also given demand and supply values. Let me start with the demand, which come just right below the box: 200, 100, 100, 300. Okay, the supply side, which is on your right, you have 150, 175. You can also have 275. So given such a transportation problem, before starting to solve anything, check whether the transportation is balanced. It's a rule before you proceed. What do we mean? Add up the supply side, which is on your right, and the demand side, which is on the bottom of your box. If the figures are equal, then the transportation is balanced. So you'll find that if you do that for this question, you'll find that both sides should both have 600. So we can proceed. We are sure that our transportation is balanced. How do you go about the Vogel's approximation method now to start this question? We first of all find what they call row differences and column differences. So if you look at this transportation, let's maybe begin with the rows. The rows, like you have row 1, let's start with the first row, which has cost values of 6, 8, and 10. That's the first row. Let's look at that row first. What do they mean by row differences? That simply means you pick the smallest number in that row, and then you also you subtract it with the second smallest number in that row. Just take note of that rule. The smallest number in that row, then you have it subtracted from the second smallest number in that row. So if you look at this question, the smallest number is what? 6. Second smallest, 8. Therefore, you get to subtract both the 8 minus 2 to get the difference of 2. Next, you go to the second row, because you're getting differences for all the rows possible that are there in this transportation problem. So we're now in row 2, which has cost values of 1, 11, and another 11. Okay, so again, the same rule, the smallest costs and the second smallest costs. As of row 2, we have 1 as the smallest cost, and then there are 2 11s, so you can just choose any one of them. So it's like 11 minus 1, 10. You put. Next, we got the last row. We only have actually 3 rows, so the last row is only 4, 5, and 12. Same rule, the smallest cost there is 4, second smallest 5. 5 minus 1, 5 minus 4 is 1. Those are your row differences. You found them. Do the same thing with the column differences. So what are the columns? The columns are these that are having the cost of like 6, 1, and 4. That is the first column. So what is the figure that we'll put as the column difference as of that first column? The smallest number in the first column is 1, and the second smallest number is 4, meaning the difference is 3. 4 minus 1 is 3. Yeah, so what I'm doing is that I'm just trying to squeeze it below here. Yeah, just to show it. Okay, that's the difference. Sorry, we're actually just mixing a bit with the number there, but just know that okay, there's a 3 there. Then the next column is only having 8, 11, and 5. The smallest figure, 5. The second smallest is 8. So the difference between 8 and 5 is yet another 3. The next one, the last column, which is column 3, has got the least figure of 10. Second least is 11, meaning the difference is 11 minus 10, 1. So after getting all those row differences and column differences, what next? The rule states that pick the highest difference that came out. It being whether it was coming from a row difference or a column difference, just pick the highest difference that came out. From what I can see, the highest difference came out in the row, in row 2, which had cost values of 1, 11, and another 11. That's the row we will begin operations on. That's the row. So once you have identified that row that you're going to start with, or whatever that column, once you've identified it, the rule yet again states that look for the smallest number in that identified row or column, which in this case is in this row, row 2. Look for the smallest number, which is of course those costs there. The smallest number is 1 as of this row we have picked. What do you do next? Once you have picked that number, you now start the normal transportation basis once you have identified a certain cell block. So we're in cell block, the cell block having a cost of 1. You ask yourself, what is the demand value and the supply value as of cell block 1? The cell block having a cost of 1. We have 200 on the demand side and we have 175 on the supply. Which figure do you allocate? The rule states that you allocate, of course, just the least number on the 2, because you can only give people what you have in capacity. You cannot go extra. So you allocate the 1, 7, and 5 there. That is the one which is allocated in that box that you have selected or cell. Then, mind you, once you have allocated something, show that it has been used up, so that you do not come back and repeat this process on a figure that has been already used up. Then do not neglect the demand side just because you did not choose the 200. Adjust the figure as well, showing that you have supplied those people with maybe a remainder of whatever will remain after you subtract. So when you subtract 175 from 200, you'll be left with a 25. Okay, next step, you have done this. What next? So what happens is, after you have just done your first allocation, the process of getting row differences and column differences is repeated again. Like, you start this process once more. So you start again, you start with the first row again and get the differences. So again, the least number in row 1 is 6, the second least is 8. The difference is 2. It hasn't changed, so I think I'll just maintain my 2 there. Yeah, next we go to row 2. As of row 2, so we repeat this whole process of getting row differences, of course, and thereafter also get new column differences. So we were in row 2, we are getting the row difference in row 2. If you can see, there are only 2 boxes left in row 2 which are unallocated, which is the 11 and the 11. So in short, you just get the difference between those same 2 numbers which are left, which is just 0. So we just allocate a new number from the 10. We can cancel off the 10. That okay, now we have a 0 as of that row as a difference. We got the third row. The third row still has all the numbers, meaning we still have the least number as 4 in the third row and the second least as 5. So 5 minus 4 is 1. So that one is maintained at least. Next, we go back the columns. On the columns, what are we able to see? What are the column differences as of column 1? We only have 6 and 4 that are left. So meaning we just get the difference of the 2, 6 minus 4, which is 2. So you just adjust there on your 3 and put a 2. The next column has all the numbers 8, 11, and 5. So of course the least number is 5, second least is 8, difference is 3, it doesn't change. Next, third column, 10, 11, and 12, same numbers as before. The difference, of course, will be 1 because the list was 10 and the second list was 11. So the difference there is 1. So after getting a second round of getting new column differences or a new column and new column differences, you now again repeat this process of which of the differences currently now is the biggest. If you look at the differences, on the row differences, we got a 2, a 0, and a 1, right? On the column differences, we got a 2. There was a certain 3 that was maintained, the 3 here, and then 1. So which one is the biggest? The 3. So the row is go for the biggest difference despite it being a column or a row. So in column 2 has yielded the biggest difference. Once you've picked out that row, you've selected a certain column. This time it's a column we have selected. Look out for the smallest number or cost value in that column. In this case, it's the 5. So once you have identified that list cell, should I say, you look at the same criteria we use in transportation. Check the demand and supply as of that cell. You'll notice that we have a 275 on the supply and we have 100 right below on the demand, meaning we allocate the smaller figure, of course, because you can only just supply what you have. This is how it is. That's the rule. So we go for the list number, which is 100, and we allocate it in that box, meaning the 100 here has what? Disappeared. And one thing I just forgot to mention to you is that once a certain figure is allocated and you've been cancelled off, maybe like the demand here, the whole column is eliminated, because if you count that column, it's now equal to what? 200. That was the figure below. It's like you fully allocated the 100 units. Same goes for that column, that row which had 175 allocated, meaning I was also supposed to just get rid of this one as well. Yeah, that is why there was been a row difference of 0, meaning everything has been allocated now and you've put in the whole 175. So once you just allocate a certain figure, if it's in a certain row, eliminate the row. In this case, we are dealing with a column. We allocated the 100 which was in a certain column, meaning the whole column what? Disappears, and you allocate only in the respective cell that needs the allocation. So this is what we are left with. What we again repeat the same process for the third time. We find row differences and column differences. That's just what the VAM is all about. So currently we have this in the first row, we have a 6 and 10 left. What's the difference there? That's 4. Okay, the 2 can go now. The difference is now 4. Next, row 2 does not exist. We said it's eliminated. Those X symbols you're seeing there. Next, third row has got 2 slots which are not allocated, so we can find the difference. Third row has the 4 and the 12. What's the difference? 8. Next, let's go to the columns. Column 1 has 6 and the 4. Difference? 2. Still there. Okay, the 2 has been maintained. Next, second column, there is nothing. It's been allocated, so 0. Next, let's go to the third column, which has 10 and 12. Difference? 2. So from that K1 which is there, we now have a 2 for the third column. You ask yourself, what is the biggest difference? Again, as of this third choosing, we have found that this time around 8 is the biggest difference. It appeared in row 3, so that is the row we will focus on. We go in that row 3, we ask ourselves which one is the smallest between 4 and 12, because these are the only left cells in row 3. Which one is the smallest? 4, because the rule says you always pick the smallest once you have selected a certain row or a column. So it's the 4. Then you ask yourself again, we have identified the cell with the 4. What is the demand and the supply in cell 4? There's 25 there, if you've seen. So that's at the corner, 25 was left. What is on the supply? On the supply, I was also supposed to adjust this 275. It was supposed to be left with a 175. Reason was that when we had taken out the 100 that time, it was tallying with the 275 line. I was supposed to adjust. We adjust both ways once we take out something. So currently there is 175. In short, that should have remained. So you have 175 on your supply, and you have the small 25 right below. Which one would you allocate? Of course, the smaller figure, 25. Of course, the 25, meaning here it disappears. 0. Then this side where this is 75, you also have to adjust it as well, because of course you just have to show that you've taken out something. You can't just leave it as it is. So 25 minus 175 leaves you with what? 150 there. Now what happens now that we have allocated the 25, And now what column was that? That was column 1, right? You can now officially cancel out that row, because that K25 that was holding on column 1 has now been gotten rid of. So everything else that is not allocated in column 1 has to go, and that's the X I've put there. What is the 6? Meaning that column has now been handled. You're left with a 10, you're left with a 12. What do you do? So at this stage, you want to know which one you start with between the 10 and the 12. So simply what you can just do here, you can choose the lists actually. Let's go for the 10 there, up there. So you'll find that if we choose that 10 there, we'll just say the cell 10 has a demand of 300 below. What about on the supply? On the supply, there is 150. We allocate the list figure, so we say 150 there, and then you cancel this 150 this side, right? Okay. Next, you only have one cell left in the whole table. By the way, let me just adjust this 300 to 150 minus 300 is 150, right? Then you have a 150 right below the demand there, and you also have a 150 to the supply, right? If they are equal, you just allocate that figure, which is 150, which will go in this last, should I say, last cell. And you have officially allocated the cells, and that's O in this transportation problem. And one thing you'll be noticing is that O is the last cell. What happens for the last cell always is that it always has equal supply and demand. Thereafter, you're safe. You can really conclude that you're safe in that case. Yeah, then thereafter, you're done with all your allocations. Yeah, I'm just trying to erase quickly, just to create some space for what I wanted to write next. Then you just end up writing now your findings that you had gotten from your table. You'll be like, okay, in that first cell, there was we had allocations like 175 in that cell, which had, should I say, a 1. Okay. The next one, you would also do the same thing, 25 in that cell, which had a cost of 4. You're multiplying, by the way, and then you add up all these things. There's that cell which had 100, cost of 5, 150, cost of 12. So once you add them up, you get the total cost using this method called the Vogel's approximation method. So this was the Vogel's approximation method, and a later video will be sent on now how to solve the stepping stone method.